We'll proceed in tedious calculus problems. Tedious calculus problems, we have taken care of the R, RC circuit and LC circuit and LR circuit. So we will proceed on this. But let's continue discussion with the kind of how to tackle multivariable calculus. We have tackled single variable calculus. Single variable calculus in the sense that what is the length of, then we will continue in complex number and those kind of, and differential equation. What is the length of this line? This is single variable calculus. What is length of this line from section x equal to x1, section x equal to x2? This is x2, this is x1, this is x-axis, this is x1 hitting here. This point is x1, y1. Now x2, this point is x2, y2. What is the length of this section from x equal to x1 to x equal to x2? From point x2, y2 to point x1, y1. What is the length? This is single variable calculus. So single variable calculus in the sense I have only one independent component, that is x-axis. That's why it is single variable calculus, because independent variable is only one. So how to tackle this? We have covered it thoroughly. How to calculate length of a straight line? Then it is very straightforward. Now, if someone try to calculate the length of the straight line, then it is someone has to represent this straight line through vector. So, if there is a consider that I want to calculate the length of this vector from point x comma y to point origin. This is origin and this is the point x comma y. Then this vector representation is xi plus yj. Then the length of this vector is x square plus y square square root. So if someone wants to get the length of a line, then line is a set of points. Each point is x comma y. X is independent component and y is dependent component. Means if I need to have dependent and independent together, then we go with the vector fundamental. So if I have a vector representation of this line, then this point is x comma y, this point is origin, then this is xi plus yj. Then the length of this line is x square plus y square, because this is the magnitude of the vector. X square plus y square square root. Very straightforward. Similarly, if I'm trying to find the length of this line, then I have to then I have to represent it through vector. Okay. Now, if I represent it through vector, vector is a straight line, not possible to represent it through vector. Here, vector. If I take the consider that I am trying to calculate the length of this line section from origin to any point x comma y. If I take x comma y and to origin, then this is this line, not this line. This is a curved line. This is a straight line. So if I take x comma y and then take it as a vector, then this is xi plus yj. In that sense, the magnitude of xi plus yj is x square plus y square square root. That is the length of the straight line connecting origin and point x comma y, not length of this line. Okay, what is difference between the straight line? What is difference between the straight line and curved line? Consider the equation of this line is y equal to x square. Y equal to x square. Okay, now in that sense, when x equal to 10, y is 100. At that point, what is y by x? That is 10. When x equal to 2, y is 4. What is y by x? Then it is 2. When x equal to 2, then y is 2. Y by x is 2. When x equal to 3, y is 3. Y is 9. Y by x is 3. X equal to 2, y is 4. Y by x is 2. X equal to 3, y by x is 3. X equal to 10, y by x is 10. Everywhere y by x is different. Whereas if it is a straight line, then every moment y by x is same, that is constant. That is the difference. Otherwise, there is no difference between a straight line and a curved line. Same thing. But curved line, y by x at every moment is different. In that sense, then we got a if I denote, if I represent any line as a vector, I have to represent any line as a vector because line length comes through the various points along the line, and each point is x comma y. It is tempting us to use vector. Vector is combination of independent component and dependent component. In 3D, it is xi plus yj plus zk, where z is dependent upon xy plane. Now, in that sense, xi plus yj is the vector representation of any straight line. It can be molded into I plus xyy, sorry, I plus y by xj whole into x. Now, y by x term is coming, that is variable, that I have to bring. Now, it is called pseudocode. Pseudocode in the sense the distance between point 0 comma 0 to point x comma y is is the magnitude of a vector, that is I plus y by xj whole multiplied by x, because y by x I wanted, because it is the item that is variable in a straight line and not a straight line. Now, in that sense, y is dependent upon x. It will be transformed into dy by dx, or the magnitude of whole is I plus y by xj into x will be 1 square plus y by x whole square root into x. Okay, y by x, since y is the numerator dependent upon x, and y by x we are trying to find that the change in y with respect to 1 unit change along x. What is the change in y I see when there is a 1 unit of change in x where y is dependent upon x? Y by x will be transformed into dy by dx. Now it is 1 square plus dy by dx whole square root into x. Now this term 1 plus dy by dx whole square root, this term is a function over x, where dy by dx will come as x only. If it is y equal to x square, dy by dx will come as 2x. So 1 plus 2x whole square root, this full term, someone can say it is a function over x. In that sense, this full is a function over x multiplied by x. Now there is a function over x multiplied by x. It will go into integral calculus. If I am multiplying two items, y into x, y is function over x, fx into x. One operand of the operator multiplication is dependent upon other operand, and that is independent component. Then it will transform into integral calculus. This is the best example of the kind of how we transform any multiplication into integral calculus. So write anything, whatever someone is trying to write anything in terms of a pseudo code, where make sure that you get y by x and y into x. I mean fx by x and fx into x. Now this is fx into x. This multiplication will be transformed into integral calculus. Now it will become square root 1 plus square root square root of 1 plus dy by dx whole square close into dx. Now x is from x1 to x2. This is what we started discussing. x1 to x2. This is to find the length of a curve. Okay, now concept is that can we find volume of a sphere? How many times you will you will calculate volume of a sphere? I am a layman. I am a layman and I want to calculate volume of a sphere. I have never heard about calculus. Okay, I am very good in numerical science. I know division, I know multiplication, I know addition, I know subtraction. How to find the volume of a 3D shape? Okay, I know one thing very well. Now consider that I am trying to find volume of a, consider this is XY plane. Up. Consider this is XY plane. On this xy plane, there is a flat thing that is kept like this. It is a stranded over in air. So there is a flat thing that is like this, that is kept on xy plane. This is xy plane and this is just hanging here. Now underneath, if I drop it, then it makes a cubical region. Okay, where this is the wall, this is the wall, this is the wall, and this is the wall, and it goes and stick on xy plane. Okay, what is the volume of this shape? What I'm trying to say, if I take it up, then it makes a cubical region. If it is like this is xy plane, then I draw the all the four sides around it. One side is like this, one side is like this, one side is like this, one side like this. Then it will make a cubical region where the top surface is this and bottom surface is xy plane. What is the volume of this underneath the surface? What is the volume of this? Okay, what is the height? Consider height is h. What is the width of this and length of this? W into L. W is the width. This is W and this is length L. And then this is the height. What is the volume of this? That is width into length into height. This is the volume of this. Anyone would reply immediately. Okay. Or someone can try, what is the height? Height is h. H into the surface area on the xy plane. That is the volume. Are you sure about it? Certainly. The height, what is your height? Height is h. And what is the area on the xy plane when it is forming? Area on the xy plane. Area on the xy plane is W into L. W into L is the area on the xy plane. Okay, multiply it with the height, you get the volume. I believe it makes sense. Okay, this is the volume. So, what about volume of a sphere? That is another question. Okay, but what is the pseudocode? What is the pseudocode to get the volume of a surface, volume of a cubical surface, flat surface? So when we try to find the volume of a sphere, start with numerical sign. That's why I say mathematics means 99% numerical sign. 1% is algebra, vector, calculus, and so many things, trigonometry, and so many things. Person who is capable of doing numerical science very well, he can only understand the future of mathematics. If numerical science is weak, then it is of no meaning. So numerical science is strong and person is quickly trying to find the volume of a sphere. If this is x-axis, this is xy plane. One is x-axis and one is y-axis. Consider the width is x and length is y. Then this surface is x into y into z. That is the height. Z into x into y. Z into xy. That is the volume of a flat surface. This is the simplest, right? So x into xy plane, height into xy plane area is the volume. Height into xy plane area is the volume. Okay, now xy plane can be written as xy, just xy, and height as z. Okay, now if someone trying to calculate for any kind of surface, then okay, we really have a kind of a sphere. Okay, so this is a sphere. I believe it doesn't look like a very neat sphere, but it is near to a sphere. How to tackle tedious problem? That is the scenario. Now this sphere is centered at the origin. This is going at the middle. This sphere is centered at the origin. In that sense, this is piercing at the middle. Half of the sphere is up and half of the sphere is down. Now if it cuts it, Then what is the height in the middle? Then what is the height of the sphere? Every moment height is different. Can you see? If I cut this, if I pierce it and place xy plane inside it, at every moment height is different. At here center, when it is centered at the origin, from the origin the maximum height is this point, and below the xy plane maximum height is this point. Otherwise, from here, from origin, if I go along x-axis, consider the radius is a. If I go along x-axis, this is the point, this is a comma 0 comma 0. Here it is point is 0 comma a comma 0. This point is minus a comma 0 comma 0. If I talk about this point, then it is 0 comma 0 comma a. This is 0 comma 0 comma minus a. Okay, then at any moment the height is different, whatever it is. What is volume of this? Calculate the volume of the top hemisphere first, then we can multiply by 2. If I calculate the volume of top hemisphere, then it is same as z into xy. This is called calculus. How we proceed is we start with the simplest case and then we proceed. What is z? Z is variable. This is algebra. Then z is square root of a square minus x square minus y square. X square plus y square plus z square equal to a square. Z equal to square root of plus minus square root of a square minus x square minus y square. Means z is this. Z is, if I take top hemisphere, then it will go from 0 to maximum square root. Everywhere it will be square root of a square minus x square minus y square for the top hemisphere. For the bottom hemisphere, it is minus square root of a square minus x square minus y square. Okay, this is considered as a kind of pseudo multivariable calculus. Pseudo multivariable calculus. So this is pseudo multivariable calculus. Z is square root. Now we are talking about top hemisphere. Z is square root of a square minus x square minus y square into xy. Now independent component is xy plane area. This is multivariable calculus. Multivariable calculus means there are two independent variables. Single variable calculus means there is one independent variable, that is x-axis. Multivariable calculus means there are two independent variables. One independent variable is x-axis and one independent variable is y-axis. Altogether we can say there is one independent surface. Rather than two independent variable x-axis and y-axis, I can say there is one independent surface variable, that is xy plane. Z into xy plane is the actual volume. Same thing. Now multiplication will transform into integral calculus because z is dependent upon xy plane. See, z equal to square root of a square, the square root of a square minus x square minus y square. Z is dependent upon x and y. If multiplication of two items comes into the picture, one integrand is dependent upon other integrand and one operand is dependent upon other operand and operator is multiplication, then happily we can transform into integral calculus. Z into xy plane into z is dependent upon xy plane. This multiplication will go in integral calculus. Now it will become z into d of xy plane. Now z equal to square root of a square minus x square minus y square into d of xy plane. Now xy plane, now d of xy plane. D of xy plane. What is d of xy plane? D of xy plane is differentiation of xy, where x and y are orthogonal to each other. Where x and y, where x and y are orthogonal to each other. In that sense, I can write this as dx dy. So it becomes now, this is how we started this calculating the volume of a cube where it was h into width into length. Then it became z into xy. Now it becomes z into dxy. Z is the square root of a square minus x square minus y square into dx dy, since xy are orthogonal to each other. So dxy plane will be broken into dx dy. Okay, if that is the case, then how I can proceed? Now, d of x dx dy, there are two independent variables, x and y. If they are independent variable, then we have to see x is from what limit to what limit and y is from what limit to what limit. Okay, when I tried this for the flat surface, same thing. Idea is same thing. We will proceed. Same thing. We will proceed for the sphere also. So if this flat surface z into dxy plane, what is it if I make it fall and this is the middle portion of this is the origin, then x is consider this is the full width and this is the full length, then x is minus w by 2 to w by 2, whereas y is minus l by 2 to l by 2. Okay, now if I think about this surface, if I think about this surface, this sphere, and it is centered, then if I see from the top, then it will make a circle here. Okay, then this is how we start with the tedious calculus problem. Okay, then it will make a circle over here. If I see from the top, it will make a circle over here. Now, when there is a circle, if it is a rectangle, then x and y are independent to each other. Okay, as far as the limit is concerned, we are not talking about dx and dy. But if it is a circle, then if I take x and y, x as minus a to plus a, then y, every moment y is dependent upon x. That is x square plus y square equal to a square is the equation of the circle. If I take a rectangle the way I took in that case, then this line and this line are orthogonal to each other. In that sense, if they are orthogonal to each other, then placing the limit as constant works. But this here, that this circle, in this circle, y is not independent of x. X square plus y square equal to a square, y equal to plus minus square root of a square minus x square. Y has dependency upon x. How we can break this dependency? Then we have to go by integration by substitution, where y equal to r cos theta, x equal to r cos theta, y equal to r sin theta. What are you saying? What is that? We will talk about. What is that? Anyway, right now x is minus a to a and y is minus square root of a square minus x square to a square root of a square minus x square. Square root of a square minus x square minus y square is z into dx dy. This is the volume that I started with the pseudo code and entered into calculating the volume of a sphere in this passage. This is how someone has to tackle the problem. Okay, now someone is free to calculate square root of a square minus x square minus y square dx dy. Okay, I mean someone is free to calculate it. Okay, if that is the case, then what it would be? Anyone would ask, then what it would be? Okay, someone can calculate. We are not forcing anyone that please use our methodology to calculate it. Like y equal to, someone say y equal to square root of a square minus x square cos theta. Just consider like this. Then dy equal to square root of a square minus x square minus sine theta d theta. If someone places it here, then the square root of a square minus x square sine theta it will become. And then dy will become square root of a square minus x square minus sine theta d theta. Whole it will become a square minus x square that I can keep outside and minus sine square theta d theta. Okay, now minus sine square d theta integration will come as minus I can keep outside minus square root of a square minus x square. Now sine square theta is theta by 2 minus sine 2 theta by 4. That is the integration. From minus square root of a square minus x square to square root of a square minus x square. Now let's make it 0 to a square root of a square minus a square. Then it will be 2 into 2 I can place, again 2 I can place outside, minus 2 square root of a square minus x square, that is outside. Limit is 0 to square root of a square minus x square. Y equal to square root of a square minus x square cos theta. This is what we said. In that sense, theta is equal to cos inverse y by square root of a square minus x square. Then y is the square root of a, then it will be 1. Cos inverse 1 is 0. And then 0, cos inverse 0 is pi by 2. So it will be pi by 2 to 0. Okay, if I had taken minus square root of a square minus x square, leave it like this. Pi by 2 to 0. Okay, because numerator is square root of a square minus x square, that will, numerator is square root of a square minus x square. Cos inverse 1, cos inverse 1 means 0. Okay, 0. 0 and pi by 2. Pi by 2 to 0. 0, then all 0. Pi by 2, then theta by 2 will become pi by 4 minus sine 2 theta is 0. Okay, so it will become like minus pi by 4. Minus is outside. It becomes pi by 4. Pi by 4, someone keep outside. 2 into pi by 4, pi by 2. Pi by 2. And then now integration of a square root of a square minus x square. Square root of a square minus x square. Sorry, a square minus x square dx. Now it will come as a square x minus x to the power 3 by 3. X is minus a to a. I can make it 0 to a. A 2 I'll keep outside. Now it is pi. Outside it is kept as pi. And now 0 to a. Now it is x a square x minus x to the power 3 by 3. If a comes, then a to the power 3 minus x to the power 3 by 3. Then it will settle at a to the power 3 by 3. A to the power 3 by 3. 2 is outside. 2 pi a to the power 3 by 3 is the volume of the top hemisphere. Multiply by 2 bottom hemisphere, because it is centered at the origin. We have taken it is centered at the origin. The top hemisphere 2 pi by 3, 2 pi by 2 by 3 pi a to the power 3 into 2. 4 by 3 pi a cube is the volume of this sphere. Can someone believe so? Quickly we calculated. Okay, no. I don't trust you. You told about that calculating the volume of a cube, but somehow you started talking about a sphere. Can you calculate the volume of a sphere in terms of a cube only? What are you talking? This is what I am talking. Can you calculate the volume of a sphere in terms of a cube only? Okay, can you transform this sphere in cubical region? Then it is easy, because limit cubical region was easy. Limit was minus w, x was minus w by 2 to w by 2, and length was minus l by 2 to l by 2. Okay, height was z into dx dy. Can you calculate it? Okay, it's possible. This is xyz plane. This is xy and this is z. If I transform it into another coordinate system, this is the Cartesian coordinate system. If I transform into another coordinate system in a way that I transform this sphere into cube, is it really possible that I can transform this sphere into a cube? It's possible. Okay, consider that. Okay, consider there is another. Consider there is another coordinate system. Okay, now we will do too many things in multivariable calculus. Multivariable calculus, where independent variable are more than one, that is multivariable calculus. Consider this is, consider this is another plane called r theta phi plane, r theta phi plane, and this is xyz plane. This is xy and height is z. This is r theta and height is phi. In that sense, on the xy plane, on the xy plane, I have a sphere. Can I use some methodology that this sphere will map into a cubicle in r theta phi plane? Can I take some relationship like that? Okay, in that sense, this is called integration by substitution. If I take y equal to r sine r cos theta, I'm sorry, x equal to r cos theta and y equal to r sine theta. Okay, then at least the limit part was a circle, if I remember. Limit part that x and y was a circle. That looks like it is transformed into a, a rectangle region. X equal to r cos theta, y equal to r sine theta. Can you prove it? Yes. What were the equations of the circle as a limit? X square plus y square equal to a square. Now x equal to a cos theta plus y equal to a sine theta. Okay, so I'm sorry, x equal to r cos theta. R is variable, theta is variable. If two independent component is there, then I have to use method of substitution for the two independent component. X equal to r cos theta, y equal to r sine theta. In that form, x square plus y square equal to r square. X square plus y square equal to r square means r square equal to a square, whatever it is. Now, it is something like that it is coming as whatever it is. I believe it is all right. I am talking too much. Anyway, the idea is that if I have a circle, if I have a circle, an equation is y equal to square root of a square minus x square. Y is dependent upon x. Y is dependent upon x. If I take y equal to r sine theta and x equal to r cos theta, then draw same thing in another plane where x axis is theta and y axis is r. Okay, there it will make a rectangle. It will make a rectangle if someone maps it. Okay, mapping in the sense that take theta, take theta the way it is. How much is the theta and x? X equal to r cos theta, y equal to r sine theta. In that sense, tan theta equal to y by x. Tan theta equal to y by x. Theta equal to tan inverse y by x. Okay, the way I take, if there is a circle, if there is a circle, along the circumference of the circle, I'm not talking about the full circle, along the circumference of the circle, there are set of points. One point is, if this radius is a, one point is 0 comma a, one point is a comma 0, one point is 0 comma minus a, one point is minus a comma 0, one point would be something like that. Take 10 points. Similarly, with that 10 points, we have set of x and y, x and y, x and y separate, x and y. Theta equal to tan inverse y by x. Now for all the 10 points, take different theta. So this is theta and this is r. Take different theta. Okay, again that theta, try to draw r. Okay, now I have r equal to x by cos theta. What is r when theta is something and x is something? Makes sense? X equal to r cos theta. R equal to x by cos theta. Now take x as a. Then cos theta. Theta is tan inverse y by x. When x is a, y is 0. Tan inverse y 0 is, I believe, 0. Cos of 0 is 1. Okay, in that sense, the radius will be x. X is a. Radius will be a. Okay, like that you try to find, it will make a rectangle. Try with, someone can try with other angle also. Okay, looks like this circle is transformed into rectangle if I keep a relationship x equal to r cos theta and y equal to r sine theta. Okay, in that sense, the limit what we had x equal to minus a to a and y equal to minus a square root of a square minus x square to square root of a square minus x square can be transformed into theta is from one constant to other constant, r is from one constant to other constant, because limit is now it is a kind of rectangle. Now z equal to square root of a square minus x square minus y square. It will transform into square root of a square minus r square. What about d of xy? Someone can use Jacobian. We will talk more on it, much more on it. So d of xy, if I try to find it in terms of r and theta, it becomes r d theta dr as per the Jacobian. R d theta dr. Now it becomes r into a square minus r into a square root of a square minus r square dr d theta. What you achieved with this? We achieved our limit is rectangular, not circle. So there it is straightforward. Someone can calculate here also. Okay, so this is that we have started discussion that how we can write pseudocode in the multi-variable calculus and we can proceed. This you are talking about integration. What about differentiation? That also we will talk. So pseudo multivariable calculus that we are talking. So we will we will proceed on this. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code 60 +91 in the India country code 9483160610 is the telephone number.